Problem 14, ladies and gentlemen. Take those notes, take them down, take a few notes. I am expecting great things from you for tomorrow. If you got some wrong, I'm guessing you didn't get a lot wrong. If you did get a lot wrong, then oh well. Problem 14 should look like this. Here is your table. Your table is the thing that looks just like when we do 2 dice and you do 1 through 6 up there and 1 through 6 here, except you're not doing dice, you're doing a spinner and flipping. So basically you've got this. Your coin, with the coin you can either get a head or a tail. Here's your coin side. With the spinner, with the spinner you can get, there's 2 reds, so I would write one as red 1, red 2, and then yellow. So your table looks like this. Here are all of your combinations. Okay. You can get a head in a red 1. You can get a tail in a red 1. You can get a head in a red 2. You can get a tail in a red 2. You can get a head in a yellow, and you can get a tail in a yellow. So this is all of your combinations. That's what they're saying by making a table. You could do it as a tree diagram and get really the same exact thing. And then for the question it asks you is, what is the probability of roll? Oh wait, that's a different one? No, that's the one of them. Oh, find the theoretical probability of each outcome. Well, and I think they're calling this, the reds the same, so the probability of getting, these, every one of them is just 1 in 6. Although they grouped the red 1s and the red 2s together, so technically they said I would give you either one. Technically, so the probability of getting a tail in a red is 2/6 because they're both red. I guess it didn't put little subscripts there, so either way I'd give it to you. So if you did head red, so you get 1/3 for this probability, 1/6 for this, 1/6 for this, 1/3 for that. Either way, I would not. You can make that case for me. Yes, Ryan.
You probably
15. 15. Probability of rolling a sum of 3 or a sum. Ladies and gentlemen, if you see there's a difference between and or. And means they both have to happen. Or means either one of them can happen. If it's an or, I'm saying you add their probabilities together. If it's an and, you multiply the probabilities together. Because your probability is greater with or. So, the rolling a sum of 3, you are going to need the little chart there. Do you have the chart? How many different ways were there to roll a 3? Out of 36, you could either get a 1 or a 2 and a 2 or a 1, right? There's no other way to get a 3, correct? So, 2 out of 36 ways you can get a 3. To that, you're adding, and remind me and I'll get you a little chart. I don't want to draw it up. You should have it somewhere looking. How many different ways to get an 11? 5 or 6 or 6 or 11. So 236 and 236 is 436. I'm hoping it's 1/9 was the answer I said, wasn't it? What's that? Yeah, I know, you've got it somewhere there. If you'd like me to make you a copy of it, I'll go for that. Or remind me and I'll put it on the board. I don't really care. I'm not concerned about your ability to do that. Just remember, or you add, I wish it was the other way around because and add will start with A, but it's not, so we don't say it like that. Or add, and means they both have to happen, so that's why you would multiply them together. Right? That is when, that was inclusive and exclusive, and that won't happen on this one. Okay, that's when 2 things could happen at once. Like probability of getting a sum of 11 and one of your dice being odd. Or one of your dice being odd. That's when you add and then subtract. That would be with an or too. But that won't come up, so don't, I hope. I should have put that in the roll. Stritzel.
Where did you get 36 from?
30, does somebody have the thing there? Oh, here it is. 36 comes from this little one that I said. This is a chart of all the different combinations of the roll you guys can get. The 36, always 36 combinations, and like I said, I will give you that chart, or I'll put it up on the board if you remind me, but. Did I give that back to the wrong person?
Yeah.
Who's supposed to? Cameron.
You know what? Number 18.
I don't know. Always good shots. Oh, really? This one, ladies and gentlemen, somebody, Alex?
100% of 35 is 35, and you multiply 35 by what's left, 40% 0.4.
Yes, or you could just, what's the word of mean?
Multiply.
Change this to a decimal, it's 1.4 times 35. Or Alex said, you could say it's 100% of 35, which is 35, and then add what 40% of 35 is, which is what, 12, 14? 49, how about that? Either way you want to think about it, I'm good with that. Schwartz. Well, I'm guessing this had a factor. The only problem with this one is that the x squared has a number in front of it. There's only one way to split up 3, Grace Watson, and that would be, right, one of them, it has to be 3x and x. Okay, and when you do this, you have to remember whatever number you put here, when you're trying to figure out this middle term, is going to get multiplied by 3. So you just have to remember that. The beauty of this is there's only one way to get 2. It's either with a 2 and a 1 or a 1 and a 2. So those are your only choices. I either have to put a 2 here and a 1 there. But if I do that, what's 2 times 3? 6. And this is a 1. There's no way to get a negative 1 with a 6 and a 1. So you want to flip those around. Put the 2 here and the 1 here. 3 times 1 is 3. There's a 2, so that's how you're going to get your 1. And this one has to be negative because you want the bigger negative. You need the 6 to be negative. Wait, that's a 1, right? You need the 1 times the 3 to be the bigger of the 2. So it ends up being 3x plus 2 minus x minus 1. And that will get you that negative 1x middle term. 12, 16. 3 times the absolute value of x equals 15. What's rule number 1 when you solve absolute value equations? You have to isolate the absolute value, which means, who asked me this? Madison? Okay, you want to get the absolute value by itself, so you gotta get rid of this 3, which means you have to divide by 3. Divide by 3. So now the absolute value of x equals 5. And then the second step is you write 2 different equations, take away the absolute value sign, make one equation with the positive of this, and make one equation with the negative of it. And it's already solved, so there's nothing more to do after that. You're going to get x plus 5x minus 5. Watson! Oh, I don't want to. Grace, what did you try for number 11? Where'd it go? On the other page. Here? What did you do, Grace? So I'm at, why do you suppose you want to find 12.5% of 2,000? The person what? here is what I would have done. Well, I won't tell you what I would have done, I'll do it the way I probably think maybe you do, but you are taking the price of the car, you're taking the total price of the car and splitting it into the commission and whatever else wasn't the commission. Okay? The total price of the car is 100%, right? The commission is 12.5, so the not commission is 88.5. Now, what of these three boxes do you know? Do you know how much the car cost? Do you know what 12.5% is, or do you know what the not commission part was? Anybody? What is 2,000? Is 2,000 how much the car cost? Was 2,000 how much the commission was, or is $2,000 how much isn't the commission? Commission of at least that. Somebody? David?
It should be 87.5%.
Oh, sorry. Mistake number 2, one more and I'm out today. You don't want me to be out. Did I write that wrong? Wow. Thanks for not pointing it out. Huh? So where's 2,000 go, Grace Watson? Is 2,000 how much the price of the car was, or how much the commission should be, or how much the not commission part should be? Yeah, so 2,000 goes right here. $2,000 is how much you want in commission. And this is what you want to know, how much did the car sell for? So 12.5 over 100 equals 2,000 over what number? And that's where you pull out the calculator, or, anybody? Yeah, 12.5 over 100 actually reduces down to what? 1/8. That's what 1/8 is as a fraction. So really, all you gotta do is multiply 8 times 2,000, which is $16,000. Now, you wanna know the way I would have done it? Back in the day, I didn't used to do this, but this makes thinking about it so much easier. I would have just said this. Because the thing says here, I would have done this. 12.5% of what number is 2,000? If that's what you're looking for. 12.5% times what number is 2,000? Because that's what I'm not even the other side. Caleb got that. Landon?
6.
Number 6. 6 is not on my paper. Any other ones? Is it up here somewhere? Write an equation for direct variation that includes the point 210. Well, first things first, Landon, what is the direct equation? What is the generic form of direct variation? We have indirect or inverse variation and direct variation. Direct variation is y equals kx. Indirect variation was y equals k over x. Right? Yeah, should go with that. So you just need to figure out what k is. And what is k? K is what you multiply x by to get y. So if you're looking at this, what do you multiply 2 by to get 10? 5. And there really is your answer, y equals 5x. If you are making a table of these values, of your x and y values, if x is 2 and y is 10, you know, if x is 3, y would have to be 15. Because if x was 6, y would have to be 30. You're just looking for the constant of variation, which is whatever times x gives you y. I think it's time to change colors. Let's go with something a little bit, something that pops. Oh,
Number 14, when you're finding the theoretical property, probability of each outcome.
Theoretically, yes.
How did you get 1/3 for the?
I got 1/3 for this because these two, if I asked you what the probability, Logan, if I asked you the probability of spinning a red on that spinner, what is it?
2/3.
2/3. Okay, we didn't separate those, no, 2/3. If I just said the spinner itself, it's 2 out of 3, right? There's 2 reds out of 3. This, when they did this, the book did not put R sub 1, R sub 2, they just put 2 reds. So the probability of spinning a tail and a red, there's 2 different ways you can do it. You can get a tail and this red, or you can get a tail and that red. So of the 6 total combinations, 2 of them, 2 out of the 6 are ways that you can get a tail and a red. Theoretically. But I was saying in the sample space, you gotta kind of put that down as 2 different reds, but they're not different reds. Maggie?
And when you're doing it for 13, for the vertical line, you just put it as the opposite for the ask for this one.
You know the what, next one?
Yeah.
Yes, because this is, in the generic equation, this is negative. So that, Maggie makes a great point. If you're looking for the vertical one, you always put the opposite of what this is here. That's why the vertical one should be positive 5. The horizontal one is whatever number is out here, which was 0. If it was a 7, the horizontal one would be 7. That would be a big thing I put in my notes. Vertical one is opposite the number that's on that bottom down there. Because if you remember, our generic thing was, I think y equals a over x minus b plus c. I think. And since this is negative, whatever number is b is its opposite when you want to know what its asymptote is. So just write that down. If it's a 6 there tomorrow, if it's a plus 6, you put minus 6. If it's a negative 12, you put positive 12. If it's a plus 15, you put negative 15. Mia,
I have 2 questions.
one at a time.
16, could I have plus or minus 5?
Yes, plus or minus would be fine.
Oh, okay, and then can you do
Who?
3?
Plus or minus. Yeah. What did you have for an answer, can I ask?
And then number 6.
Well, here's the deal with problem number 3, ladies and gentlemen. You have to think of radical signs like letters or variables. They have to be identical for you to put them together. If this would have been a square root of y and that would have been a square root of x, you couldn't have done anything to those. That's already simplified. But since they're the same, you can put them together. What does this mean? 7 times the square root of x plus y means I have, oh, sing along, Claire, you know the song. 7 times the square root of xy means I have 7 xy's, 7 positive xy's here. Let me go ahead. 4. Sorry, xy, sorry, it's xy, not x plus y. Plus the square root of xy plus the square root of xy. That's what 7 times xy, just like 7 times 6 is 6 plus 6 plus 6 plus 6, 7 times. 7 xy's is 7 xy's. Now, what am I doing? I am taking 5 of them away. Minus 5 of them. Minus 1, minus 2, minus 3, minus 4, minus 5. What am I left with? I'm left with 2 square roots of xy. Now, if it's times, that's a different story, but this is adding. Just like if this was 7x minus 5x, you get 2x. Not x, but y. That's a moment. 12 or 20? Scroll on this page here. Oh boy. Really? 12, ladies and gentlemen, if you're struggling with this really doesn't get any easier than this. You're writing the compound inequality. Was this Madison? Left side, right side, x in the middle, have to be less than signs. You can't do it the other way. It makes no sense the other way. This is open circle, so there's no equal sign. This is closed circle, there is an equal sign. X is greater than -3 and less than or equal to 4. Alex.
For number 17, you explain how we got 39 from the equation.
Oh, snap on the message. What? 17? Wait, you're explaining how I got 39. Wait, you have to go all the way back from where we found the slope and then put the.
No, I've got the equation now.
What was the equation?
Y equals 7x
Plus 2? And if x is 5, 7 times 5 plus 2 is 7. Is there another way to do that? Did anybody else come up with another way to get that one from? We can't do 7. Huh? Well, as long as you know that the common factor is 7, it's good. I mean, you could, if you do it like this, what was 2 shirts for $16 and 3 shirts were $23. You know, if you're doing this on your little thing here, you know 1 shirt has to cost how much? $7. So 4 shirts would cost you $30. Or you'd say, well, if each shirt is $7, 7 times 2 doesn't give you 16. 7 times 2 is only 14, so you'd have to take the shirt and add an extra $2 to it. 3 times 7 is 21 plus 2 is 23. So you could do it without doing that whole slope thing if your mind can think that way, but I'm not 150,000% sure that everybody's got that. Stritzel,
How do you do 19 and 20?
both
Yeah.
at one time or at different times? Well, 19 is just like solving an equation. Okay, and if I had 6x minus 5 equals -23, how would you solve that? Okay, so I add 5. -23 plus 5 is a -18. And then the last thing you would do is
5 by 6.
divide by 6. And that's where x is less than or equal to -3. Graphing it. At -3, it's a closed circle and it goes this way because the little arrow is left. Remember, the only time you have to worry about switching the arrows is if this is a negative variable, which it's not in either one of these. So, and the same thing is true for this one, Caitlin. How do I get x by itself here? Yep. What's -1 minus 3? -4. And x is greater than -4.
I just always mess up on the graph part. The line.
Well, just remember, this little arrow is the same little arrow as the same little arrow. Greater than numbers go bigger this way. Number line gets bigger going that way. Would that help?
Yeah.
Purdue. What? Which one? E? Oh yeah. Do not forget when you come to these factoring things, your first thing is to try to factor, if you can factor something out of all 3. Do they all have a common factor? Yes, they all have x's, and they also all have x squared. You can take 2 x's out of all of them, leaving you with an x squared here, leaving you with that 7x, leaving you with that 12. And then once you get there, don't forget that x squared has to stay outside when you factor this into 2 binomials. Only way to get x squared is x and x, and then what number added together, or multiplied together gives you 12, added together gives you 7. 3 and 4. And you could, somebody asked, does the order matter? No, you could put the +4 there and the +3 there. Same thing for problem number 9, except this is just a trinomial. You can't factor anything out of all 3 of them, so here, what times what gives you 12, added together gives you 8. We can't use 3 and 4 because that's only 7. 12 and 1 would give you 13. 6 and 2 would give you the 8x there. Logan, 15 again. You can't do the problems too many times. Alright, you're gonna force me to draw my little thing here?
No, I mean, but, no, you don't have to, but I don't understand, what do you do after you have 2 over 36 plus 2 over 36?
Well, that's 436, you just reduce it.
Oh.
236 plus 236 is 436. I understand how that's confusing. Just remember, ors get added together, ands get multiplied. I'm going to do the rest using complete squares. Watch how this works. Cameron? Number 8. Oh, I don't remember what 8 was. It sounds familiar though. I did just do that. What movie was that? Come on. Your favorite movie that you never watched before that you saw today. Well, because 7x cubed, if you factor 7x cubed out, it's 7 times x times x times x, there's 3 x's. If I factor an x squared out, I'm taking 2 of those out, putting it out here, so I'm left with the 1x there. Dividing, taking out, dividing, 7x cubed divided by x squared. Take those x's out, they're left with 1x there. That help? Okay, Brian.
For problems like 8 through 10, how would you know for sure if you're using subtraction conditions?
For these,
Yeah.
well, you look at this, the only way, Kebron, to get a positive number here and a positive number there is for both of them to be positive. Okay? Your choices are, if the last number is a positive number, this number either has to be positive or negative, duh, right? If this number is a negative and this is positive, they both have to be negatives. Because the only way to get a positive here and a negative there is to have a negative and a negative. It won't work any other way. That maybe makes sense, I don't know if that makes sense to me. The only way for them both to be positive here is for them both to be positive. If this was a negative 12, then one has to be negative, one has to be positive, because there's no other way to get negatives. If they're positive at the end, either both negatives or both positive. Had this been a negative 8x, this would have had, both of these would have had to been negative. Beauty of math, kids. By the way, this is hard math. Don't let anybody fool you that if you can do this, you're in pretty good shape for next year. Okay, math kids?
On the test, we have to do number 7.
What was number 7? You get those.
Investigation.
It's up there.
Very
so
good.
it's friends on there.
Oh, no, you won't ever do that. I should talk about it, but it's. Joint variation is just the same, except you have a couple extra numbers to multiply. No. Remind me though, we might have to talk about joint variation. Variation. When y is 7, y varies jointly, that means y equals x. You've got 2 things you multiply with. Is there anything else out there? Because I feel very good about this test. Especially since I don't have to think it. Which ones haven't we done?
Number 2.
Number 2, do I need to go over positive and negative correlations? Number 1,
Number 1,
One was just lot.
well, number 1 is just, they want you to think in terms of,
Or just
We
yes
actually
or
have
no.
to put,
If you have to explain
just
it.
quick yes or no. One might be different tomorrow. If they're going the same rate of speed, which is the same slope, by the way. Speed is a miles per hour. You know, if you're going, if this guy's going 5 miles per hour and this guy's going 5 miles per hour, they'll never, if they don't leave at the same time, if they left at the same time, what would it be? That's a good idea, that's a good thought. If these people left at the same time, they'd have the same y-intercept,
Would be the same thing.
which means they would always be walking together. You know, let's say they both left at 1 o'clock and they're both going 5 miles an hour. The graph of one line is gonna be the graph of the other line, and the other gonna be there. But if they left at separate times and they're going the same speed, it doesn't matter what the speed is, they will never ever cross each other. What's the other choice? Different speeds, then they have to cross somewhere.
That means be moving.
You can go backwards. Can speed ever be negative? Can distance ever be negative? Can time ever be